morning. Thanks to all of you to stay here, and even to people that are linked by our YouTube channel. Thanks to Ian to be here and for this interesting presentation of CostFact that is for me a real important tool for our development. I want to thanks Ian for his effort, for his commitment with this presentation, and I just want to arrange a very light presentation of what MICAD is and what we do in our office here in Trieste and by the way even in Lecce. And after this first point, we are going to leave the stage to Ian for the presentation of for the deep presentation of CostFact tool. So thank you, Ian, for to be here, and we will enjoy your presentation in a few minutes.
Thank you very much for the introduction. Welcome everybody on-site and online. Before I will start with the presentation, I think Daniele will tell something about current projects, and after that I will jump in and start with a custom presentation.
Okay. Thank you. So just 5 minutes for what we do in MICAD. We are a design house active in all sea-related industries, and we want to give support to our customers for in all the design stage of activities. And we have a good relationship with our customers because we are flexible and we try to follow them for all possible needs they have, considering different aspects, because we want to be to care about innovation, functionality, not keeping in mind the safety of our of the products of our customer develop, and elegance as well. We are a small company, but we are growing. In the last 6 years, we have this increase of people working in MICAD, and particularly here in Trieste office, we have a research and development office that is really active. So the growth is we have in the last 4 years is particularly due to this new office here in Trieste, and even activities in the turnover of MICAD is growing as well. So we are quite happy, and this is also due to the growth of the nautical sector where we are really active. Here you can see some of the boats we followed in the past. We have different activities that we offer to our customers. As you can see, Veneto Group is one of our for sure our most important customer, particularly here in Friuli Venezia Giulia with Monte Carlo yachts, but not only, because we also work with Veneto in France, and we are really happy for that. As you can see, we not all the design, not all the project is developed by MICAD, but we have to consider different approach that we need to offer to our customers, and one of the most difficult part to be in this market is to be able to arrange cooperation with different companies, different suppliers, and this is a really challenging activity. What we do is project and project management that is necessary if you want to do that job, and concept design, really advanced 3D modeling that could arrive to the file for the CNC machine, interior design, of course, naval architecture and marine engineering, propulsion in particular, and engine room layout, structural design, system design, and we also offer some help during the process development of our customers that are normally industrial customers. But we also have some services we do. That is a service for test, for activities of reverse engineering, or even products with additive manufacturing. And of course, we are active in the classification and certification of the boat we work on. And we have a good team for research, development, and innovation. So you can see here some of the activities in more details. Of course, we arrange CFD calculation, FEM, or whatever it necessary for the job. Our research and development activities are largely financed by the Regione Friuli-Venezia Giulia, but not only. We also have we have European projects, of course, and even some projects of research and development even in Regione Puglia. We have different projects. Today, Daniele is Bruno, that is our innovation manager, will present the activities in the innovation we are doing even with Katalin and the rest of the team for software development. Thank you.
Thank you, Amedeo. Possible to go forward with the presentation, or I have to change the...
I think you have to change.
Thank you. I'm Daniele Bruno. I'm deal with the innovation for MICAD, and I'm going to present two of our research programs we are involved in particular for the software development. We start with the project Calc. The aim is to develop a software that can help shipyards or designer in general to calculate the load cases for all kind of vessels. As you know, it's very important to estimate the weights and the center of gravity of any floating vessel. And our software has the possibility to estimate the weight, to estimate all the mass properties of the weight, inertia and so on, but offer also certain feature like the monitor of the weight, for example, during the services, connected with in the next future, connecting the software with all the equipment and the sensor presence on board. The aim is also to develop a technical configurator for a short series production for that shipyard that have this need, for example. This project is financed under the Rilancio Impresa FVG, also for proposal of the Friuli-Venezia Giulia region, and the conclusion is planned for May 2019. The software, the interface is completely available on web or app interface. And the infrastructure is hosted completely online in cloud. These are the three main aspects I would like to show this morning. Starting from the concept. We have three main aspects we follow. Firstly, to develop a software included in a single framework. All the feature, all the calculation, all the function are included in a single Windows, in a single framework. Then the calculation of the mass properties are even more available by the estimation or the analysis of past project, archived project. And then also with the parametric approach, but for the next. And the other point is the division of the items list of the items that components the bot in a specific specific working breakdown structure. As you can see in the next slide, we have a proposal of the working breakdown structure, but it's also customizable from the user. Just in review of the other point, the estimation is provide differentiation among the version, propulsion system, serials or registration number as you can call, and the revision, of course. Statistical regression are made with a parametric approach, and of course the results, load condition, are replaced from the standard rules available in the sector, in the field. For example, ISO rule or ISO preset. About the management and the report, we provide some preset of reports, of course, to provide a fast user report, but it's possible also to customize all the entry of the reports and to have also a graphical analysis of the results and correlation between the results and the key parameters input. About the users and the policy of permission to operate inside the software, there is a complete management of the user, differentiation by roles, and a strong login system. The code is completely developed in Java, and connection with the MySQL database is provided by a cloud infrastructure in which a dedicated server is operated only for our customer. The landing page of the software, just an overview, just a schematic representation of the software, because the project, of course, is under development, so we don't have a beta version at the moment, but only a scheme of the function. The landing page for the shipyard is reachable by a login inside the MiCAD web page, just an authentication on the website. Then the second step of the authentication provided by at the moment by the Google Authenticator. That means you have to generate a token with another device, a key or a smartphone or another device to check the identity of that user, and then the access to the personal dashboard of the shipyard, of the designer, of the user. The dashboard of the user of the shipyard provide, of course, a list of the current project, and of course the possibility to add new project, for example, and to manage the project in progress with the differentiation by registration numbers, for example, or series of that vessel. And of course the possibility to access to archived projects. Here just a scheme of the management of the user. It's possible to control which users are present in that project, selecting one of the specific projects. It's possible to add a new user. It's possible to check the status of the user for instance, which user is online, which user are offline, or if a specific user are working on is working on a project. Then the first phase of the workflow to set a job inside this code. The general data of the bot. In particular, it's possible to configure, of course, some information like the length, the beam, the number of the crew, the number of crew present on board, but also other data like which are the codification of the registration number, for example, like a numbers or an array of numbers or a specific code that belong to that particular shipyard, for example. It's possible to set version, the name of all the version present for the vessel. It's possible to set the propulsion system plan to install. So all the general categories in which it's possible to divide the items present, or the items that the shipyard needs to calculate, are all these categories are possible to set in this part of the software. Here the working breakdown structure. It's possible, of course, to adopt the proposal by MICAD, the MICAD VBS, but in any case, it's possible to customize this list or to add a new list. In this case, we propose a division of the working breakdown structure made by jobs, dividing the main categories in the main jobs. This example is related to, of course, yachting, or in general vessel made by composite materials. Of course, for this reason, you can see the first column GRP, but the other are the same. The other column, the other jobs are the same for all kind of vessel. And these lists are customizable from the user, and it's possible also to create new lists, new customized lists. Here, the core of the software, the item list, the receipt of the company. So here, just an example of two main components: the engine and the gearbox. But of course, it's possible for any kind of vessel to customize the single entry, the single item, inserting all the characteristics, also the properties of this item, and of course its weight and its central of the coordinates of central of gravity. It's possible to insert, or we provide three kind of three approach to insert a new item, starting from the database MICAD, is sort of catalog in which MICAD has stored some large number of items coming from some agreements that MICAD during this research program has to start to agree with the major supplier of the nautical and naval fields. Of course, it's present an approach that provides the possibility to insert manually all the properties of an item, and of course the possibility to analyze an archived project in order to collect some items, but also some parts of information related to an item. Just an easy example. For a new project, I would like to have all the information related to the gearbox ZF 2550 but I have to change, of course, the weight and the central, the coordinates of central of gravity, and I have I need these possibilities. Optional fittings. This part is very important for yachting, for the yachting field. And our approach in this case is to manage more than one list of optional. In particular, as you can see in the slide, there is a wide possibility to customize the lists, adding a new list or modifying a list already present. It's possible, of course, to link the item marked as an optional to other items present on board, like the liquids, for example, or special tanks need only for that item, for that marked optional item. And so the connection between items and the load case are bidirectional. I mean, so it's possible to customize the item, the optional, taking into account the modification inside the other parts of the calculation. Just an overview of the reports. It's possible after a configuration of the specific version you want to view, to analyze, setting, for example, which version you need, which propulsion system, and for which registration number. It's possible to make all the to calculate all the results. In this case, for example, according to ISO rules, in which it's possible to differentiate the results for the empty craft condition, the light craft condition, and so on. But it's possible also to export a report in a standard form, in a standard layout, but also a customizable layout. The last part of this software, this presentation, regards the analysis of the results. It's possible, based on the item list, it's possible to reorganize the value, the results value, in order to analyze the composition of the boat in terms of weight, of course, and thanks to some advanced charts like bubble charts in this case, it's possible to catch, to understand, to deep understand how are distributed the weight on board. In this case, it's possible to see a three-dimensional graph, a three-dimensional chart, in which the dimension of the circle are the dimension of the weight, or the entity of the weight. The color is instead differentiation by the jobs or the working background. In this case, in this way, it's possible also to differentiate this kind of graph for specific, for example, jobs, in order to analyze which job has the maximum weight on the results of the total. So until now, I talk about Calc, one of our research program. Just two slides on another tool that we are developing. Dyne's is a tool to predict the hull resistance for planing hull. Daniel is based on Daniel-Savitzky method, of course, and some more effective correction of this. The results of the tool, the feature of this tool is to provide an estimation of hull resistance, an estimation of the trim, running trim for several speeds, and also the accelerations in rough sea, or an estimation of the acceleration in rough seas. Also, this tool is completely programmed in Java, and the database on the basis of the database is MySQL, and the interface is available online by web or app interface. The input of this tool is, of course, the load condition. For this reason, we develop another tool that can work together with the calc, with calc software, and to catch, and it's possible to, in this case, to catch the data from calc in order to estimate instantaneously the behavior of the boat on during its service. Of course, the other input are the main geometric parameters, all the data related to the superstructure, to the propellers, for example. Then the calculation of the mechanism provided by the method with some correction provided by the literature, or also coming from some analysis, some study that MIGAD has conducted in the last years, also by other research programs like Sophia, for example. And like output, we have, of course, the resistance of the hull, the maximum speed reachable, the fuel consumption, and trim angles, and as I said before, the main accelerations in graphs. Thank you very much, and I leave the stage to Ian for the presentation of CostFact. Thank you.
Yeah. So I will continue with the topic on cost management. First of all, I'd like to show you this brief overview on the program today. The first topic we already saw, so the welcome address and information on the current projects, projects. And so we are right here, 30, nearly in time. First of all, I would like to give an introduction to this topic, and then we will address some special features like regression analysis, how to calculate ship series, especially important in yard building, boat building. Earlier or later, it will be time for a short break to recover. And then in the second part, we have two more topics. So one is how to integrate the specification in the calculation in order to make sure that the calculation really fits to the demands of the customer. And finally, also an overview on life cycle costing. So incorporating also the in-service phase and optimizing the cost of the in-service phase. And of course, there should be also time for questions and answers. And as Amedeo already said, if you have questions which you consider to be important for the current topic and you think they are of interest for all, so please don't hesitate to interrupt me. And then we try to handle this. First thing, I'd like to start with a short introduction of myself and the CostFact company. So it started 2001. It was in a cooperation with University of Chemnitz. In the beginning, it was pure consulting services. The topic was cost-efficient design. So it was about how to reduce costs by applying special methods like value analysis or target costing in the process of design and engineering. So far, nothing to do with shipbuilding, just plant engineering, traditional mechanical engineering. And during these consulting projects, there was immediately the demand to create software tools to support these projects. So when the question was, well, we have an existing plant and we want to optimize the cost, the first step is, of course, to analyze the cost. A lot of calculation systems do not support this. So we build our own cost analysis tool. For the next thing, if you have alternative designs, and of course you want to assess them regarding the expected cost, then you have to make a cost prediction. And so for this need, we had to create cost prototypes. And so after some time, we had a couple of different software tools supporting cost estimation, cost planning, cost analysis. And the idea was, why not taking all these different tools together in order to create one comprehensive software system. So when that was finalized, the idea was, okay, now we have this good tool, why not provide it to the market? And then there have been such a lot of different other tools from competitors doing the same. The idea was to specialize on one branch. And because the previous project has been plant engineering that needs unit production, big complex projects, the idea was, is there perhaps a branch that is similar to this? And so the idea was to approach the shipbuilding market. And so we are in the year of 2008, when there was a need, okay, now when we are talking about shipbuilding, cost management and shipbuilding, we need knowledge about shipbuilding. And then we entered in the cooperation with Technical University of Berlin, and there was a department of design operation of maritime systems. And the head of this department, he was working for nearly 15 years for Flensburger shipbuilders. He had a lot of experience in this topic, and he was interested in it and said, yes, let's do it together. And that was the point in time that we transferred this existing general program into a specialized program tailored for ship and superyacht building. Well, today, CostFact is purely the software tool, the program, exclusively for shipbuilding and yacht building. Besides the company CostFact, there's another company involved in the production, that is Tensoft, that's an IT company, exactly the same size like Mikot, 14 persons, 2 general managers and 12 employees. They are not only working for CostFact, they have also other clients, but if there's a need for capacity in order to customize it for clients or to create interfaces to the existing environment, everything like this is done by Tensoft. Current shipyards using CostFact. Here we are. Are mainly from Europe. There are also some from Asia and South Africa. But more important for me is to demonstrate with this chart that there's a wide range of types of shipyards using CostFact. So there are very big shipyards employing several thousand workers, like for marine systems, but also very small shipyards, like this one. As you can imagine from the logo, that's a family with something like 25 persons overall in the shipyard. There is naval projects like marine systems, but also yacht building and also series production like absolute yachts. So CostFact is capable to satisfy the needs of very different types of ship and yachts and boat builders. The software, the presentation itself contains both information about CostFact, something like 70%, but also information about the methods CostFact make use of for cost estimation, cost prediction, and so on. And at the beginning, I had the presentation divided into 2 parts. The first part was a theory part, and the second part was the CostFact pure software part. But it was not so convenient. So in the beginning, in the first part, I always had to say, okay, that is the method, and later on, in the second part, I will show you how software makes use of it. And in the second part, I have to say, okay, now we're coming to this feature, and I hope you remember, in the first part, I explained this method. And so I changed it, and here in this presentation, CostFact, the software system CostFact, is used as the backbone of the presentation. So we will start right from the beginning with a product CostFact, a software tool, and case by case, the different methods are explained as soon as they become relevant. So by doing so, I will start with CostFact, and before going into the single features and details, I'd like to give you an overview of the entire CostFact. So what is the main idea of this CostFact? How should CostFact support cost management? And the first thing is that CostFact is capable to integrate really all cost-relevant information. So in the center is always a current project, and our aim is to estimate the cost and calculate the budgets, and later on to control it during production. And to do so, CostFact can, in the beginning, import the specification delivered by the client. CostFact can host the different technical parameters of the ship, so there's a connection to the technical parts. CostFact can administer the unit rates for labor hours, for consumption material. There are interfaces to import existing calculations from spreadsheets like Excel files to make them available after installing CostFact. Of course, there are links to the ERP system. For instance, to track the consumptions of material, labor hours. Like Daniel already mentioned in the beginning, in the context of the NICA tools, everything is carried out according to the breakdown structure. The same applies for CostFact. So in CostFact already are several breakdown structures implemented, but the user is free to import additional ones, or perhaps the client has a breakdown structure and says, I'd like to receive the offer in my breakdown structure. So it's possible to import it. Okay, it's possible to administer proposals of the user suppliers, the shipyard suppliers, to work with estimation factors, so to address the effect of price increases over time. Of course, manual inputs can be done. And most important, when working on a current project, it's always possible to access very easily existing projects in order to reuse information which are valuable for the current project. And based on this idea on the reuse of existing information, a typical costing procedure with CostFact is not to create each project from the green field with a zero-based budgeting, but to say, do we have a similar project from the past? If so, we will make a copy of it and then just modify it. But even if there isn't any similar projects at all, there might be the possibility to say, okay, no similar project at all, but perhaps an existing project where the propulsion plant is similar. When I can identify such a project, I can take this part of the project and very easily import it into the current project. And by doing so, I can run through the different existing projects and collect the different data needed for the current project together. So that hopefully only a very small part in the end have to be calculated manually. That has, of course, the advantage that it's much quicker. On the other side, it's more reliable because I'm not starting guessing any figures. I reuse existing information that is already proven. Another way of reusing existing information is the regression analysis. So it's supporting the parametric costing approach. So here the idea is to say, when I have to estimate, let's say, for instance, the cost of the propulsion system, and I only have the information about the requested power of the propulsion system, how to make a cost prediction. And here with CostFact, we can analyze existing projects and contrasting the parameter, in this case, the requested propulsion power, with the cost of the existing projects, of the propulsion system, of course. In this case, we see each dot is one project from the past. They're more or less on a line, so we can calculate this so-called regression function. And this regression cost function can later on in a current project be used to estimate the cost just based on the requested propulsion power. Finally, everything of costing is carried out in this I call it calculation view of CostFact. So that's the main calculation window. So here on the left side, there's a breakdown structure. So there's an individual breakdown structure of the shipyard. So with different levels, the blue items are the groups, the elements of the breakdown structure. And these groups, in the beginning, they are entirely empty. They have to be populated with the components or the cost items. So these are the black ones. So These cost items are assigned, allocated to the groups. Here on the right side, we have all the information about labor hours, about the cost and these things. They are summarized according to the breakdown structure. So on each level, I have the total of the cost in this part of the calculation. So here in this example, partial units is selected. So these labor hours and euros in this case, which are shown in this highlighted row, these are the totals of all the groups and subgroups, including the components on the deeper levels. The other way, if I go on the higher levels, I will have on the topmost level, so the first row, I have the complete project. So I can address at each level of each stage of the project, the beginning, rough information, I will look at the higher levels, and then going more and more in detail to the different components on the final groups of the breakdown structure. So very brief summary, different approaches of costing which are used in CostFact. So 3 different approaches. The first one are the top-down approaches. So here it's called the logi approach. So searching for something similar and reusing it. Or the second one, parametric approach, making a regression analysis, calculating the regression function, using this function to predict cost. And the third one, bottom up, it's called engineering approach. So when I look at the single components and work that has to be done on the single elements of the breakdown structure, and then this cost is summarized. As soon as I enter something in CostFact, it doesn't matter if I apply the regression function or if I enter something manually, everything is tracked in a cost history that is automatically created. And that's especially helpful if a couple of different users are working together on a project, and especially when reusing information from other projects, and you see a figure, you have, okay, it's 100,000 euros, but if you have no idea, was it just a rough estimate or was it a detailed calculation, then you don't know, can you rely on this information or not. In this CostFact, you have attached to this value the information which user entered it in which project and what was the source. Was it a manual input or was it the utilization of a cost norm? And so there's always permanent information control about this. Of course, cost can be implemented in the existing environment. I think that is clear and self-evident, so there's nothing to say about this. So typically it's connected to the ERP system in order to reuse unit rates like labor hour rates and these things, or also to transfer budgets from CostFact into the ERP system. And well, when thinking about the advantages when working with CostFact, here I spent some thoughts how I can what is the best description of this advantage. And my only idea was to say, avoid spreadsheet counts. And that is when, once again, the different persons are working in a company and everyone has his own way to calculate. And then you have, for one project, a lot of different spreadsheets and tables. And if you like to reuse something, or even if you like to analyze existing calculation in order to say, is it reliable, yes or no, often you're lost. Because every calculation has its own structure and different versions. You're not sure which is the latest version, and so on. And working with CostFact, it is provided that all projects have the same structure, very clear, are comparable. And of course, something like this, what is quite typical for calculation with cost, this Excel spreadsheet, will not quite happen. So if you have a complex calculation with totals and subtotals, and a lot of formulas, there's one single mistake somewhere, you have a mistake in your entire calculation in the resulting proposal that you send to your client. So that's the last chart referring to my opinion, main advantages of CostFact. The next thing is, and that's especially important after the presentation. When you saw all the different features of CostFact, you might say, okay, you can really do a lot with it, but probably it requires a lot of training to get familiar with it. And in fact, it doesn't, because CostFact is structured that way that the basic features, setting up a new calculation, modifying a calculation, can be carried out more or less after 3 hours training is more than enough. So everybody who is experienced with calculation and is used to calculate in the breakdown structure will be very, very quickly able to do the same in cost. Right, here an overview of the system structure. So it's very simple. In the center, always the current project with a calculation, which has to be populated with cost, and then different ways to get the information into CostFact. So here, external sources, basic structures, or especially in the beginning, existing calculation and spreadsheets, which can be imported, ERP system, actual cost, but also unit rates and these things. Then reusing previous projects, either by importing something directly into the new calculation or by analyzing it, regression analysis, and then applying the cost norms. And of course, everything can be entered manually directly in the current project as well. I forgot to mention in the beginning, typically the specification is imported. So if you receive it as a Word document, you can import it and it's automatically split and attached to different elements of the breakdown structure. And on the other side, of course, it's possible to analyze the calculation in order to find cost reduction potential and so on. Okay, this next chart, the skip, is just the different stages and how to reuse the different, or how to use the different informations, but that will be shown later on when we look at CostFact itself. Okay, the first chapter is the main basic calculation features of CostFact. And when we start here, okay, once again, still looking at the execution of the program. After starting CostFact, this window is shown where we see all the different projects. So each row is one project. After selecting one project, we have for this project more information. So for instance, we have already different versions for this project created. We have the technical parameters. In practice, will be much more, of course. And if you like to edit a project, just double click on it, and then this calculation view I already showed, or part of it I showed beforehand, is open. Here the calculation is carried out, so the calculation work is done. So, and instead of, say, to create a new project that's entirely empty at the beginning, instead of entering all the things manually, the first step is typically to say, well, isn't there something similar we can reuse? So that is an approach of what's called case-based reasoning. So it sounds complex for a very simple thing. So the first thing is to say, okay, we have a new problem. So we have a request from a potential client, and we have to predict cost. And then to say, okay, we never built this type of vessel before, or this vessel before with this specification, but we built a couple of vessels over the last years. And of course, we have the information available. So have a look in this. It's called case memory. Is there something that can be reused? And if it's not the entire ship, it's perhaps a part of it. And if we find something, so that is, according to the technical parameters, similar, we have this so-called retrieve case or cases. On the other side, we have a new problem, and then we have to compare it. And because it's not exactly the same, we have to modify the retrieve cases and create a new suggestion. So this one has to be analyzed, approved. Is it suitable, yes or no? And when we say yes, it's suitable, we have a confirmed solution that can be used for a new project. And of course, it also runs in this case memory. So the case memory, which is nothing else than our project administration CostFact, is getting better and better over the time. So this works in CostFact like this. In this case, enter a new project. That means we have on the left side our breakdown structure, completely empty, so no figures at all. And here we say, okay, we are interested, we have to calculate the propulsion plant. I'm responsible for the propulsion plant. So the first thing is to say, let's have a look, is there information that can be reused? And to do so, I select it, click with the mouse right, and I have this menu, and here one item is import cost. And after selecting this menu item, we see all the existing projects, each row one project, with information for this selected group. So here's 2000 propulsion plant. So here we can analyze it. So if I might think, okay, this seems similar or comparable, to go in depth, I can open up a preview of the calculation. So we have all the information about the applied components and other technical information. Necessary to close this calculation, go to the project administration. So I see it from here, and after I select a project and say, yes, that is comparable with a new one, I confirm, and my CostFact compares both projects before importing it. For instance, there's a possibility to apply the indexation factors. Perhaps other project is very similar concerning the technical demands, but it was calculated 3 years ago, and of course prices changed over the last 3 years. So that can be handled by applying these index values. This vendor is centrally administered. And finally, I have, when I confirm, this part imported into my new project. So with some mouse clicks, I have already nearly finished the calculation of the Python. You can also say, okay, I can make manual updates, modifications, when I say, okay, now we reduced our labor costs by 5%. I can enter it here and apply it instead of making manually. But earlier or later, of course, I will have to do some manual inputs or modification, and that is carried out in this window. So this window is pulled up by selecting the main calculation view. So I request an element of the breakdown structure. In this case, it's still 2,300 propulsion units. I'm double-clicking on it. I open this window and here make all the manual inputs, which are perhaps still necessary. So the different components shown here in this row, these are the same components shown as cost items in the breakdown structure beforehand. So, of course, I can enter commentary and so on. I can use unit rates. So these unit rates are administered project-related. Unit rates, for instance, for manufacturing, we have different cost centers, welding, steel cutting, or whatever, with unit rates. They are administered here, the same as for different material types. Can be entered here manually. It can also be imported from the ERP system. So when a company is working with SAP, they have all these rates in the SAP system that can be imported. So, and then I can make use of these cost rates or unit rates when I'm working in this window. Instead of entering these costs manually, I double-click on the unit column. Then I see these unit rate groups, and here I select the requested unit rate. And then applying, confirming, accordingly the values are entered in this in the corresponding columns. And of course, advantages when later on the unit rate changes, or when I reuse this part of the project in a new project 2 years later with other unit rates, everything will be, or it's possible to update everything automatically instead of going to all the different places where the unit rate is applied and modifying it there. The next topic is about using parametric information for cost calculation. So we have the possibility to administer technical parameters like X over all, hull weight, hull surface, and so on. And in this window, the attributes or the figures for the different parameters are entered. And here, in this case, I already see that the hull weight, which is in this case 590 tons, is used as a technical parameter for cost calculation for 3 different cost items. So I see the group where it's used, and I also see in which case it's used. So later on, yes, jump to the next thing. And later on, or here in this window, instead of entering the quantity manually, I can once again double-click on it and select parametric cost calculation. then I open this window. And here in this window, I see all the parameters. And when I say, okay, my task is to calculate the number of labor hours steel work, and when I know, okay, there is I know the relation between the hull weight and the number of steel weight, I double click on it and open up this window. Here I have different parameters. Then I select the hull weight, because I want to refer on the hull weight and calculating the labor hours steel work. Here I select the function type. 4 or 5 different function types available. In this case, easy, linear. And my knowledge is that 1 ton steel requires 200 labor hours steel work. So I enter this relation here, 150 some initial work. No, I made a mistake. 150 hours per ton plus 200 hours initial work. And after applying, CostFact calculates these 107,000 hours automatically. So up to now, not such a big advantage compared to making it with a pocket calculator, but of course, when it later on changes, and the hull weight changes, or I reuse a part of the calculation in a new project, I just go to this administration of the parameters, update the number of hull weight tons here in this window, get the information, okay, it is used, this 3 different places it is used, and here you see the different parts, and after confirming, the calculation will be automatically new calculated based on the new number of hull weight. Okay, so as I have different sources or ways to populate this table with the cost, I can make manual inputs, I can make use of unit rates, I can make use of technical parameters, I can also refer to other rows in this window. Perhaps I have steel entered and then I want to calculate steel waste. Based on the entered steel, I can refer to the other one, like you are used to do with Excel. So different sources, and to ensure that there's all this overview, I have these notes as these icons in the beginning, and here I see, okay, there's a parametric function used, and the unit rate is based on material rate. And selecting the row, I have also this information here. Well, here, oops, that was the break. Here I also see this already mentioned cost history. So for each single cost item, I have this complete cost history available. And for the currently selected item, I see how was this item created. Here I see it was in February 2015, external imports, so probably an import of an Excel spreadsheet, in this project by this user, and then what happened. And here we see, okay, there have been cost factors applied, and then transferred from one project to another one. And I always see which was the number of euros at this point in time. And this cost history can also be used in order to display the changes over a period. Let's say I'm responsible for group 5000. I'm 1 week on holiday, come back and see prices change. I'm interested in seeing, well, what was the reason. So I can select in the first step the group, the breakdown structure I'm interested in, always including all subordinate groups. Then I enter the periods I want to analyze, and then I say, show me all changes made in this part of the calculation in this period. And then I get the list, and after selecting one, I see the complete history. What happened? And then I can ask my colleague, what did you do? So with CostFact, I can calculate variance. So perhaps we are looking how to reduce cost, or we have some options we like to offer to our client. So it's not necessary to make a second calculation. I make one basic calculation, and by checking or unchecking single components or parts of the project, I can exclude or include them. I can administer up to 3 additional variants with CostFact. I can attach documents. So perhaps I have a proposal from a supplier, and I received it by email and have a PDF document. I can attach it, same as for drawings, and all types of file types. Right, then we have a look at the breakdown structure. That is the backbone of the calculation itself. Can be important, so as mentioned at the beginning, if you have it available in Excel, just copy and paste it and then import it. Then you can define ship types. That is important because the main idea of CostFact is to say we have one basic structure, and we try to calculate our different parts of or different types of ships and boats all in one structure. And the reason is just that this procedure enables us to exchange information between the different projects. If each project has a single structure, it wouldn't be possible, because when I look at Group 4000 in one project and the other one doesn't have a Group 4000 at all, or perhaps it's 4000 stands for something else, then it's not possible to exchange the data. And here, so the idea is to say we have one basic structure covering everything, all different types of ships, and then we define ship types. So saying we have, for instance, a lot of CostFact users, they are building both naval ships as well as super yachts. And they have only one structure, and then they can say super yacht don't has the group 7000 armament. So just unchecking it, and that makes it possible to apply the same breakdown structure for all projects. So then it's possible to define relations between the different structures. That's especially important if your client says, here's my own structure, and I'd like to receive a proposal in my breakdown structure. And then you have a problem because you're used to your structure, and then you always have to transfer it from your calculation structure to the one of your client. Here with CostFact, you can define the correlations and say, okay, the yellow one is the one from our customer, our client, and these groups, our own ones, can be assigned, allocated to the different groups of the client. And by doing so when this is once done, the calculation can always be transferred from your own structure. So here we see the blue structure, our own breakdown structure. We have different cost items allocated to this 2,300, and then transfer it to the structure of the client, which is this one. And here we see, based on the previously defined relations, the cost items are reallocated to the elements of the client's breakdown structure. So here, in this case, we see propulsion diesel engines. Originally 2,300. Here's still the information in brackets, and now it's assigned to the 2,100. What is the corresponding element of the client's breakdown structure? And accordingly, the usual calculation procedure in CostFact, all the costs are calculated. So we have, even in the breakdown structure of the client, on each level, the resulting cost available. And here they can be printed, and our proposal can be created based on this alternative structure. Finally, it's also possible to allocate single elements, components, to different breakdown structures simultaneously. So perhaps your standard structure is s.r.l breakdown structure, but then you have another department. Perhaps the design department is using another structure than the costing department. Or the next departure, business development, whatever, is calculating based on the stages of the project. And so there's a need to assign one component, one cost item, to different breakdown structures. So that can be also done. So you can project-related import different breakdown structures, and then you can allocate one component for each structure simultaneously. You still have one basic structure for calculation, but you can display the calculation in each of the other structures. Any questions so far? If not, I continue with, so that was after finishing this. Thank you. After showing you the basic procedure in CostFact, so how to calculate, we're coming to the next step to the cost management itself. So up to now, well, we estimated cost, hopefully more efficiently than the spreadsheets. But now the question how to optimize costs. So how to try to make it better, the cost itself, to reduce it. And here I start with target costing. And target costing is the idea to say, not like it's done as a usual way in previous times, to say, here, following up the bottom-up pricing, to say, okay, we have our design, and based on our design, we calculate the cost, or we estimate the cost, make our cost budget, and then we add our earnings and risk surcharges and all these things. And based on this, we have our market price. And then we send our proposal to our client and say, that is our price. So this procedure has a disadvantage that there's a risk to lose a contract just because we are too expensive and a competitor has a better price. And so the idea of target costing is to say, it goes a separate way. We make a top-down costing. We start with the market price. We think about like discussing with our client and looking left and right, what are the prices of the other competitors, try to find out. Then we say, what is the market price? We think if we are able to reach this price, we will get this project. Of course, it's applicable for all types of products. So in this case, you have a boat or a ship, and say, we guess that is our market price, and our job is to reach this market price. So then we say, okay, we have to take something off because of earnings, risk, and so on, and that leads us to the allowed production cost. So that is our aim. So if we are responsible for the cost-efficient design, it's our job to reach these target costs. So, and when we go this way, saying, okay, we offer based on this market price, of course, if we are too expensive, if we are not able to reach this market price, then we have a problem as well, because we have the job, so the project, but we lose money. And to avoid this, target costing provides special methods. Here in CostFact, it is done this way to keep the overview on it, to work with this target cost sheet, starting to set a cost target for the entire ship. So in this case, 38 million. So we believe when we are able to make a design that cost by 38 million euro, we will win the project. And then the next step is to break this total target cost down to different main groups. So it also can be done at additional level. I prefer this one, just addressing the main groups. And saying, okay, based on our experience from the past, of course it's ship type specific, we split this total target cost by these percentages to the different main groups. So here these percentages are entered as well, and based on the total target cost and the percentages, the different allowed costs for the different main groups are calculated. So in this window, nothing else is entered than the blue number, so that is total target cost and the percentages. So and this is done, not when I have my first cost estimate. This is done right at the beginning when I received the request from the client, from the client to say I have a request from the client. Then I try to guess what is the price I will be able to get the project. And then I have in this very first stage already this column filled with an allowed cost for the different main groups. And then in the next step, when the first initial design is available and the first budget costs are calculated in CostFact, in the calculation view, this column is populated automatically. So these numbers here are exactly the same like we see it in the calculation view. So, and by doing so, in this very early stage, I can compare the target cost with the planned cost. And well, here you see that's a cost overrun by 8%. So we have to reduce the cost by these 8%. And instead of saying, okay, cost reduction required 8%, everything is reduced by 8%, that's probably not practical. If there's a system from a supplier and I know that is the final price, there will be no negotiation be helpful, I cannot change it anymore. And it's also not efficient to try to reduce the cost by 8% for some single small items. The idea of target costing is to say we have the allowed costs, group specific, and we have the total overrun. Now let's have a look in the next step where this total overrun results from. And here in this example, we see there are 1, 2, 3, perhaps 4 main groups which have a very high cost overrun. And so we have the information to analyze what is the reason, why do we have such a big overrun here in the hull structure. And then by addressing these groups with the highest overrun, we will probably be much more efficient. Okay, the same procedure can of course be done when the project is running, so production. Then we have actual costs, and as soon as a design is frozen, there's only very few possibility to reduce cost. So the main application of this window is a very early cost. Then we have a plan controlling of these different types of costs, overrun, and so on. It's also possible to define milestones in CostFact. So once again, in the same window shown before, we have in column milestone, and here it's possible to select for each cost item the milestone, which means at which milestone the cost will become relevant. It's not only possible to select one milestone. You have 3 columns for all. You might have an additional payment, and then you can say, okay, the additional payment is done at milestone number 3, and then you have a continuous payment until milestone number 5, and then all costs is paid. And based on this information, the calculation is analyzed. So here's a blue line. These are the expected incurrence of our cost based on the milestone. You see until number 12, when the project is finished, how it increases, and then it's possible to contrast it, this red line, to the actual cost. And so especially when you're during production, so for instance, when we say we have milestone number 6, we see, well, up to now, this cost incurred, and our allowed cost is wrong example. I select number 5. If you have number 5 and you like to analyze the cost, and you see, okay, there's something like 22 million euro incurred cost. Well, our allowed planned cost is 36 million or something like this. That's of course not allowed because it doesn't include all the expected costs. And with this window, you can compare directly milestone related. You see the actual cost is 22 million. They are higher than the up to milestone number 5 allowed cost. So this way, there's a possibility to make an ongoing controlling during the production. The same can be carried out in this window by saying, show me only up the costs by milestone number 5. So we see in this column for the planned cost, only the part of the cost which is allowed to incur by milestone number 5. Change order management is especially important in shipbuilding because complex projects and nearly always also the design is frozen and the contracts are signed. Earlier or later, the client will come and say, well, I have a new idea and we have to change it. And of course, we don't want to say no because it's our client. But on the other hand, we have to track this cost to be able all the time to say what has been the cost based on our initial design and what is the cost based by change or caused by change orders that arose later on. And the cost factor is done by the change order management module. So here's the possibility to define in this window change orders. So in practical projects, you have typically a couple of different hundreds of change orders. So they are entered here. By default, they have the status of in process, so they are still pending. And then you might offer them to the client, then he says yes, and it becomes an accepted change order, or it says no, then it becomes an turned down change order. and this is managed here in this window. And in the calculation view, here's a column, the green back color column, where we can select the change order, and then we say, okay, this cost item or these cost items, they belong not to the basic design, that's caused by a change order. We can select one of the different change orders, and by doing so, these cost items are assigned to the change order. And here we see when we select a change order, we see here all the different cost items, components dedicated to this change order. So in this case, it's boring because they're all in the same group, but in practice, typically a change order affects a lot of different groups of the breakdown structure, and that's the reason that it's hard to track because they're divided over the entire calculation. And with this procedure, you have always overview which costs belong to one selected change order. Of course, it can be analyzed as well to see, well, the cost structure of different change orders can be analyzed in the calculation. So here, by default, only the change orders with status accepted are running in the calculation. All the other ones are set to 0. But if you like to know, well, I'm interested in well, what would happen if I accept all outstanding change orders or something like this, you can check these boxes accordingly, and the calculation is including or excluding the change orders. In the same way, you could be say, I want to see only the change order costs, and you can say excluding, and all other costs which are no change orders are set to 0. So I think I can also, good for this already. So I make this next chapter, and I think it's a suitable time to make a short break. So it's about cost analysis, exports, and reports. There are different features in CostFact that are supporting it. So always the question, of course, is, well, we have it calculated, so we have a result, but we're interested in what is the cost structure in order to minimize costs, in order to track costs. So here in CostFact, as soon as I select one item in the breakdown structure, I see for this selected structure, in this case 1,100, the hull, the entire quantity structure, so how many labor hours, how many steel tons, and so on, are in this group. I can go more in-depth, analyze it. First step, selecting the part of the project I'm interested in. Here's the entire propulsion plant. Pulling up this window, I see cost structure, all these things. I can make a so-called ABC analysis. I think probably you all know about this effect, that if you compare cost structure or other structures, it's often the case that if you just take the most expensive parts, that a few parts or a few portion of all parts, often something like 20%, already causes 80% of the total cost. So referring to a ship, it might say, well, 20% of the components, the most expensive 20% of components already causes 80% of the total cost of the ship. And so it's, of course, much more efficient to say, well, when looking for a cost reduction potential, we look at these components. And CostFact supports this by this analysis, where you, once again, the first step, select the group you're interested in, might be the entire project, and just select the topmost node, then pulling up this window, and here we see the most expensive component. So it starts with the most expensive one. In this case, it was an inland vessel, so here it was a crane, at 75,000 euro. That already has a cost share for this selected group of 27%. And then the next one is this anchor captain, and so on. And here we see with saying something like the first 9 components, so just the first most expensive 9 components, already causes 80% of the total cost. And so, of course, we will look at these components when we are trying to find alternatives. So it's possible to define categories, to be very flexible in analyzing a calculation. So that's an example from Southern African shipbuilders. So they have to show how much of the ship will be built inside of the country of South Africa, and how much will be gain value outside. And so they created just two categories, local and foreign. And then they had to add or to assign for each component to select one of the categories. And based on this information, they can later on say, okay, 62% is produced locally, and that's sufficient. The next thing, so we are once again getting a bit more to the theory part, but that's also in practice very important. So that's a feature I know every prospect client makes use of this very intensively. That is the question, how reliable is a cost estimate? So when you finish everything and you have the information, okay, prospective cost is 1 million euro, then it's quite interesting in knowing is it plus minus 2% because there are some uncertainties in it, or is it plus minus 20%? And this question or this task is covered by this feature of CostFact, which calculates the prospective resulting calculation error. And by calculating this, this value, CostFact makes use of the so-called Gaussian error compensation. Looks perhaps complicated, but it's quite easy. That's about when there's some calculation or a cost prediction, and we have an object, and we make this prediction referring to the entire object, and we say, well, I guess it's 100 euro, and I'm wrong by 10%. Then I will be finally wrong by plus minus 10%. But if I divide this object into single parts, and I make my cost estimate for each single part separately, and let's say I have 5 single estimates, and I'm still wrong by plus minus 10%, I will probably, in the end, better than plus minus 10%, perhaps only plus minus 7%, because when I have it divided into single estimates, I will have the one time I will be too expensive, too high, and the other, in the next guess, I will be probably, or perhaps too low. And that means the higher the number of single estimates, the stronger the effect of error compensation. Well, that can be calculated. Can be also carried out with Excel, so that's for itself, it's no need to make it go for CostFact. Here's an example from the beginning where this is calculated with Excel spreadsheet. So we have the different components, then we have our different cost forecasts, and then, well, in the next step, it would be necessary to say, well, I have made this cost forecast, 36,000, and then how reliable is it probably? How much percent plus minus? And nobody knows, or nobody is capable to say, well, I think it's plus minus 5%, my guess. So, and to make it practical, the way is to define, here it's called hardness grades or risk classes. And to say, well, we have one risk class, number 1 is plus minus 35%, number 2 is plus minus 15%, number 3 is not shown here, perhaps plus minus 5%. And then the users just ask to say, okay, for each estimate, select one of the risk classes. Is it very reliable or not reliable? And that is practical. And based on this information, in this case Excel, in the other case CostFact, is calculating the resulting error. And here we see the resulting expected error is plus minus 7.5%. Also here a lot of that 35%, 50%. So in CostFact it looks like this. So here centrally define these risk classes. Here's space for up to 5 different risk classes. So here we say what is the error we allow for each risk class. Here's between 0% and 30%. And the comment is just for the user to give an advice when to use which risk class. And in the calculation, it's possible to select for each cost item one of the risk classes. In the same way, it would be possible to say, I imported a group from another project and I like to apply plus minus, or the risk class number 3 comparison project for the entire for this entire imported part as one. And as soon as all components have a risk class dedicated to, I can run this analysis. So here in this case, I selected the entire project, my example project. Here we see how the cost items or components split or are divided over the different risk classes. So you see here this one, hardness weight 2, what means plus minus 20%, is assigned to 25% of the components. No, not to the components, but to the cost of the components. And well, the main information of this analysis is this value here, saying, based on this assignments of the different risk classes, the expected resulting forecast error is plus minus 5%. And with this information, the top management can say, okay, that's reliable enough for us, and we can make our proposal based on our existing estimate. But perhaps there's plus minus 12%, and then the management might say, no, the risk is too high. Please qualify your estimate by waiting for additional supplier proposals or going more in detail when calculating. So I think that's nearly the last slide for analysis is a possibility to compare projects or project revisions. So when I created a revision of a project and after 1 month I see the total, well, it's got much more expensive, but what happened to the project? I can select both revisions and then pull up this window where these revisions can be compared. So here's the breakdown structure. Already the differences are shown between both selected projects or revisions. And when I see, okay, in this case, I have a cost increasement of more than 6 million euro, what happened? I can select it. On the right side, I see the one project, in this case, a different project, and the other one, you can see in detail the different cost items in each project. Okay, then the question of reports, so you can create different reports with CostFact, export it to Excel as well. All information in CostFact, all costing information can be exported, so even if there's a report not existing in CostFact, it's possible to export it into Excel and to finalize analysis with Excel spreadsheets. So the next chapter is a bigger one, capability costing. So first of all, questions so far? If not, everything was clear, everything was so unclear that there's no possibility to ask. Perhaps we can also discuss things in the break. So if you agree, we could make a short break. Yeah. If that's okay. Ready? Okay. So we come to the second part. Now here we continue with this capability costing. That is one of the advanced features. To my knowledge, CostFact is the only software supporting it. We have a practical example from ThyssenKrupp Marine Systems, which made use of this feature. Well, ThyssenKrupp Marine Systems is building naval ships, and when developing a new product family, they realized that they are too expensive. So the first calculation showed that they are too expensive. It was not too expensive by 5 or 10%, it was too expensive by 30%. So the question is how to reduce cost by 30%. And I think it's obvious that's not to be done by looking at each system can reduce the cost by 30%. There's a new approach required. And that is here carried out with so-called capability costing. The idea of capability costing is to say, let's go a step away from the systems and all the things which are combined with a design. Let's try to have a look at the vessel from the client's point of view. So what does the client require from a ship? And in the next step, what is the value of the different features the client require compared to each other? Some of the requirements are probably more important for the client, and other ones are less important. And that's on the one side, the view of the customer. So in our case, it was the sales department taking care about and trying to take the client's point of view. And on the other side, it's the costing side. So that's about calculating the cost of the different capabilities. So the idea of this capability costing is to compare the value of a capability with the cost of a capability. And if there's a capability which has only a minor value for the client, but incurs a lot of cost, then the idea is to say we concentrate on this capability. Is it really necessary? Is there possible an alternative way how this capability can be fulfilled by other systems? So the aim is to get a balanced relation between the value and the cost. So that means our job was, or working with CostFact, is to try to calculate the cost of the capabilities. So not the cost of the different systems and components, but the cost of the capabilities. And so the first step was to define the capabilities, and it was on a very rough level. So just these different 5 main capabilities. So it was offensive effectiveness, survivability, mobility, surveillance, and standards. And for each of these different capabilities, sub-functions have to be defined. And this was carried out in CostFact in this window. So the first step was to create a new capability tree. Here it was named Compact Vessel. And the next step, this function tree was created. So on the first level, we had our 5 different main capabilities, offensive effectiveness, vulnerability, and so on. And for each of these main capabilities, the question which functions are required to fulfill this capability. So here in this example of survivability, we had 4 different sub-functions. So it was NBC protection, redundancy, signature reduction, and shock. Yeah. And for shock and signature reduction, there have been 2 additional sub-functions. So up to now, it was completely without looking at the systems, without looking at the cost. The correlation between the capability view and our breakdown structure view, what means the systems, that was made in this window. So here on the left side, we have our capabilities on the complete function tree. And then in the next step, it has to be defined for each of the different capabilities. In this case, here it's selected NBC protection. Which groups take part in fulfilling this capability. So here there are several groups, so climate control is getting more expensive if NBC protection should be fulfilled. The same is for the ventilation system and other systems. But nevertheless, even if I don't have any NBC protection at all, I still have the requirement, or I still have the need to have a climate control system. So it would be wrong to say I assign the entire climate control to this NBC protection, but instead only a part of it. In this case, it was selected 40% of the cost of the climate control are affected by this function NBC protection. And accordingly, here 40% was selected, and then the climate control was moved, 40% of it was moved into this field, which means it is dedicated as 40% to this function. And based on these allocations, in the next step, the calculation, here the conventional form, all our breakdown structure groups, and all the costs resulting from the different cost items, can be transferred in the other view. So here, I've shown this example with air conditioning package. So that's 2,180,000 euro running in the group air conditioning system. And after transferring the calculation into this view with the different capabilities, the air conditioning package with the cost, 60% of the cost, which means 1,300,000, is dedicated to the NBC protection. And accordingly, the cost of the different capabilities are calculated just by summarizing the assigned cost. So here we see the total cost overall with the same number because we're analyzing the entire ship, the capabilities of the entire ship. And here in this case, we see that the functionality or capability, 20 survivability, causes cost by 20,600,000 euro. So that was our contribution to this capability costing, that we were able to present the cost of the entire ship according to the different capabilities. And in the next step, outside of CostFact, the capabilities were compared regarding their cost and the value, the expected value for the customer. So the current cost share, that's exactly from the chart before. So surveillance has a cost share of something like 12%. And the value for the customer, which is the same like the driven share of the total target cost, was made with something like 70%. So in this case, the value for the customer is higher than the cost. But here in this case, offensive effectiveness, here we see it on the left upper part of the chart. Here we see the actual cost. They are higher, or the portion of the actual cost is higher than the portion of the value for the customer. And the result from this complete analysis was to say, when we are trying to reduce the entire cost by 30%, we do not look how can we reduce the cost for surveillance, for survivability. We address mobility and the offensive effectiveness. And by going this way, that we have an information on saying, okay, we spend too much money for this. It's not so important. It's still the most important one for the client, but not in the balance with the actual cost. And is there the possibility to use another system that is cheaper, perhaps fulfills only 80% of the original requirements, but it's much cheaper, and we are able to replace the original system because we know from this information that it is not so important for the client like the actual cost. And by going this way, we are not trying to reduce the cost of a special system, but we replace it by another one. Or perhaps we have another design solution saying this original system is not necessary anymore at all. And then the entire cost is set to zero or not reduced by 30%. So message is a complete other view on the costing in order to get cost-cutting potentials which are much higher than addressing the single systems of a The next thing is about calculation with data imported from CAD or CAD system. As shown before, we have the possibility to integrate technical parameters into CostFact. The idea is to say we have on the one side, we have our CAD system, and here we have in cooperation with a ship constructor, and we have a prototype that is enables to exchange the bills of material. So that means the ship constructor system is providing the bills of material of a ship. This is imported by CostFact. And on the other side, we have the ERP system from the client. We are directly connected to it. So based on the material codes, we can get as far as it's available in the ERP system, the costs of different material parts, and have more or less automatically an entire calculation in CostFact. So here we have this interface. So for our prototype, ship constructor creates an CSV file with the material information. Then we have this interface. CostFact runs a consistency check. Here in this case, there's something wrong with it. Okay, here it already checks. Is a unit rate available in this project? In this case, it isn't. So it's up to the user to define what should happen with this cost item. And finally, it's imported. So it means without a lot of manual work, you have your first cost prototype in CostFact available. So the last part, the last charts from the first part is user rights and access to projects. So it's standard, so it CostFact has possibility to define different user roles, profiles, who's allowed to do what. Here, power user is allowed to manage everything. Then you can administer the different users, assign them to a profile. More important, or perhaps more interesting, is that CostFact provides the possibility to work simultaneously on one project, different users. So here it is carried out this way, that the user selects in the first part not the entire project you want to edit, but only the part he is responsible for. And the next one can open this window as well. And here we see when we want to edit this project, this gas tanker, we see somebody is already working on the propulsion plant. So here we see it is locked, so we cannot edit it anymore, select it anymore, but the hull structure is still available because there's another user. And so I can open the hull structure and work on this group in the same time. And still it is ensured that there will be no mess by different users changing the same figures. So we finished the basic calculation features of CostFact. The next one, I think here are some strong similarities to the parametric calculation we heard this morning about, is how regression analysis can be carried out with CostFact. The methodological background, quite easy, and everybody involved in costing and shipbuilding knows about this, is the fact that typically there are cost drivers which can be used to predict the cost of different parts of the ship, so main groups or groups of the ship. So, for instance, the length overall might be an indicator on cost driver for the cost of the hull, the required speed and power for the machinery and propulsion system, and so on. And in practice, I think each shipyard has its own created parametric information in order to calculate or to predict cost. So I know from some super yacht builders, some say we have 12 different of these parameters, and our first cost indication we create just by using these 12 different numbers. So only very few. To get a bit more precise, CostFact offers the possibility to predict cost based on these cost functions. Okay, here's some examples for cost drivers and corresponding groups. The main idea, just as shown in the beginning, is to say, is there a correlation between a cost driver, here in this case it's length overall, and here the production cost. So that is not too long ago, I know at least in Germany, the superyacht builders, they say, well, to get a first idea of the cost of a new superyacht, it's only important to know the length. And something like 10 years ago, they said 1 meter length costs €1 billion. And if you ask them now, they say, well, no, that's not completely valid anymore. Take 2 million per meter. But for me, it's a bit strange that when they say, well, it fits plus minus 50%, that they make use of it because probably plus minus 50% is not suitable. So, but here to make it, to give an easy example, here it's shown based on this parameter. We have the length of all, we have the production cost, and by analyzing the different existing projects, we're trying to create such a regression function. And the next step when such a regression function is created is, of course, to get an idea how reliable is it. And one information that can be used with care is a so-called stability index. So the stability index bases on the differences between the single points of the sample and the regression function itself. Here in this case, it would say we have this distance between the medium and the line itself. And in this case, it would say something like 50% of the deviation from the medium is results from the parameter used to create this regression function. But obviously, there's still another distance which is not affected by this cost driver. So obviously, there are other cost influencers which are not captured by this analysis. And so, based on these spreads, the resulting stability index is calculated. But as I say, it has to be handled with really big care. The reason is, let's say you have only a sample data of only 2 objects. You will have a linear line running through both objects, and you will have a stability index of 100%. So it seems to be perfect because both dots are lying on the line, but in reality that's of course nonsense because it doesn't matter where these dots are. Maybe one is here, the other one is here. You can draw a line through them, and you have the regression function, which is obviously not of any value, but you still have a stability index of 100%. So the message is, even if there's an advice, a statistical advice, like the stability index, when working with this feature of regression function, it's always important and absolutely necessary that the user working with this program module still is thinking about what he's doing and trying by himself to evaluate the result of the regression function. So that's not a procedure that can be carried out automatically. It is still up to the user who is doing it, trying to think about it. Okay, in CostFact here we see how it fits in the system structure. So it works by making reuse of existing information, creating the regression functions, and that is one feature that can be used to support the user. That is to define for each of the different technical parameters, for instance, your propulsion power, what are potential cost drivers. So here we have all, no, wrong direction. So for each cost driver, propulsion power, what are the potential elements of the breakdown structure which are influenced by a change of this selected parameter. So here on the right side, in the beginning, all different elements of the breakdown structure. And then after selecting a parameter, it can be said which of these elements are influenced by this parameter, and they are moved into this list in the middle. So here we see we have this elements of the background structure selected and say they are potentially are affected by the propulsion power. So when this forward is done, of course, all the different attributes have to be filled within the projects to make them usable for the regression analysis. So to say what is the hull weight of this project, what is the propulsion power, and so on. And when we have the sample data available from projects from the past, we can carry out a new regression analysis in this window. The first step is to select what do we like to, what's our regression object. So when we want to set up a cost norm for which object it shall apply. And here we select the propulsion power and the propulsion plant. After selecting an object here in this drop-down menu, we see here in the parameter list, we see the different technical parameters which may have cost influence on this part of the ship. The content of the second list is always the same. Here we say what is the cost type or unit we like to analyze. Do we like to analyze the influence on the material costs or on the labor costs, or perhaps also on the labor hours, so the number of labor hours? So that's selected here. And as soon as I select in both lists one entry, this list on the bottom part is filled with all existing projects, the existing ships or boats which have been calculated, and also provide information about the selected parameter. So here we see something like 8 or 10 projects which have parameters, that is the propulsion power, and the cost for the selected group, so here 2000. So here we see the same in this chart. The next step is probably to say, okay, now I have all projects here in this list, but probably not all of them are comparable to my new analysis or to my new project. So it's up to the user to define which have to be excluded from the list. That's one thing. The other thing is to say, well, these projects from the past, probably they spread about a period of 2, 3, or 5 years. And here we see, in this case, we select the production cost. We see the cost according to all the different points in time. But our regression analysis, our cost norm, it should be applied or will be applied for a current project that will be built next year. So we have to adapt it to the price level from 2020. And to do so, we can make use of this indexation table and say index all or escalate all these different projects to the selected point in time. So the next step is to say which of them should not run into the evaluation. And here we deselected this Berm tool because we analyzed, we took the quick view, and then we saw, okay, there's another propulsion provider, system provider, so we deselected because not comparable to our new project. And the remaining projects, which are not we came across, they will still run into the analysis. And then you can say calculate regression. When doing so, CostFact calculates for different types of regression functions: linear, potential, logarithmic, exponential, which are often seen in practice, and proposes the one with the highest stability index. So in this case, it's a logarithmic one, and the user is free to select another one. So if I say, well, in this case, logarithmic might be the one with the high stability index, but my experience says the correlation between propulsion power and production cost is linear, I could select the other one. But here, propulsion power, probably plus 10% more propulsion power will affect a little bit less than 10% more production cost. So I remain with a logarithmic function and will make use of this later on. Of course, still up to the user to incorporate knowledge like for more than 14,000 kilowatt, we will have another type of propulsion system. So to not extrapolate this calculate the regression function. So, but finally, when I'm happy with this function, okay, maybe I analyze a little bit the outliers. So I see all of them are plus minus 10% in this range. When I'm happy with this, I have two different ways to make use of this resulting regression function. So one is to use it directly for a current project. So we have a project and I know the requested power is 8,500 kilowatt. I can enter it here, click perform estimate, and then I see here's a red dot, expected cost of 5,200,000. The other way of making use of this result is to store this function in the cost norm pool. That is here, add to norms. When I click here, it runs in this norm pool or cost function pool, where I can make use of it later on when I'm in the calculation, so that is valid accessible across projects. And so in this case, here we see there's one norm which automatically has a comment result regression analysis, but it's also possible to enter this manually. So if I have some knowledge gained over the last years, then I can enter this information here. It becomes a regression function or a cost norm which is available across projects and can be used by other users to calculate the cost, like shown in the beginning when we make use of this window. Instead of entering it here manually, I can also click on function pool and then I see the list and can select one of these norms. So I think that's the point where you have to jump to.
Yeah.
Okay, next is about calculation of ship program. So especially important also in yard building and boat building, when it's not only about one vessel to be built, but a series or a program of ships. Then, okay, here's an example from naval ships, where we have typically the effect when we build, in this case, 3 different ships, that the second one requires much less engineering work than the first one, and the third still less. But perhaps there's only an effect that some cost will incur not for the first ship, but for the second or third one. In this example, we say, or it was said, that the first ships were built on their own shipyard, and the third one in the client's company abroad. And then there was additional supervision abroad necessary, and that applies only to the third ship. So, and to handle these effects, CostFact provides some functionalities. And what also has to be considered is that ship series typically will take a couple of different years or a big number of years. So if you have like here 72 months, it means 6 years, which have to be incorporated in the calculation. That means that the effect of interest of price escalation has to be considered as well, of course. So to do this is CostFact. There's the approach to say we have on the one side we have the incurrence of cost, to say we have one value we enter. We always enter only one cost item once for all ships, but then we can say it's total applicable for the first of class, second of class only 70%, and the third of class for third ship of program only 65%. So that this is accordingly distributed of the different ships in program. Furthermore, it's possible to say in which point in time the cost will incur. So to define the different periods, for instance, month of the program, and then to distribute the cost over different periods. To say this first cost, perhaps engineering cost, will not all take place in the first month, but it will take place over the first 4 months. And then it can be defined as well. Based on the escalation factors, the index values you saw before, the resulting values can be calculated. So here it looks like this, that we define in the project administration for a project in this example 4 different ships, so not only one, like before, but 4 different ships. For each ship, it can be defined what cost incurrence will take place. And there are different possibilities. Here on the one side, I have the, it's called regression ship program, that's nothing else than a learning curve. So to say, when I do something not only once, but 2 or more times, I will probably have the second time less effort than the first one. And of course, this effect becomes stronger, for instance, for engineering cost, because especially in the beginning, there's a lot of engineering work, later on less engineering work, but also manufacturing, what is required for each ship in the program, will become more efficient. The first time I make some mistakes, I will not do a second time again. And so we can define for different cost classes the learning curve. So here it says object material, so provided by suppliers, will always remain the same for all the different ships and programs. Engineering, 100% for the first ship, the second one only 45%, and getting less. Service, external suppliers, that was negotiated as well, a reduction, and so on. So that is a learning curve. And the other one is in current ship program, where I can set up manually different occurrence curves. So for instance, to say 4 things which will be only applicable for the third of class, I enter it here by supervision abroad. I create this new occurrence curve here in this window, and then I can define explicitly about the percentages of the ship program. And here say it will only occur with 100% for the first of class. So here we are very flexible to define or to address such special requirements. So we see once again, this is used as well. Here we can define the distribution for cost over the program. So for instance, when I say engineering cost will only occur over the first year of the 12 months, it can be inserted here as well. And finally, when I'm working here in this entry window, I can select an occurrence curve and a distribution. So occurrence curves, I have by default, I have non-recurrent curves. That means only the first of class has this cost. Recurrent cost digression, that means all the costs, all the ships will have this cost, but it will be reduced by the learning curve. And then I can also select one of the individually created curves, like the supervision approach. And the same is for distribution. Here I can select one of the different distributions I created beforehand. But based on this procedure, I only have to calculate the first ship, and all the additional ships in the program are calculated automatically based on the initial value, and then incorporating the occurrence curve and the learning curve. So I see in one project, production cost plan, that's the first ship, and I also see a second ship, third ship, and the fourth ship, how it's reduced, and here I see the total cost of the entire program. In practice, it's often like saying the client says, yes, we like to have 4 ships, and then optionally additional 2 ones. And that can be also handled or addressed by this possibility to check or uncheck such ships. That means you will always calculate the entire project. If you see no, the client doesn't take the option, you just uncheck the ones which are not required and have the remaining cost of the ship program. Was this understandable? Yeah. Okay. Then the second last big module is a specification. So the specification you either receive from your clients, big document saying that is what we want, or also the specification you create by yourself, the building specification. So CostFact has room for 2 different specifications. They are administered in the same structure like the calculation. So here we are in the calculation module. On the left side, we have the calculation structure, or the background structure. And then we have place for first and second specification. In this case, it's called short specification, full specification. And here the specification text can be entered or changed, like you know from Microsoft Word. as soon as somebody enters something here in the specification module, makes a change, CostFact automatically checks, is there already cost calculated? And if so, the user will get this advice shown. Take care, the specification was changed, and there's already cost calculated. Does your change has any influence on the specification? And if so, the user confirms with yes. And then in the calculation module, where perhaps another user is working on the calculation, there will be this list showing all changes which have been created in the specification and are not considered yet in the calculation. So the guy doing the calculation will select one of the still unconsidered one, here in red. See the specification text, the new specification text, together with a comment from the one doing the specification, and then he can integrate this information, this change, into the calculation. So it's just to ensure that the specification always matches the calculation. Okay, that's possible to set up text modules, so for specification text that is often used, so not just to enter it again or to have a separate Word document. You can have structured according to breakdown structure, structured text modules, which can be used when working on the specification. You can use the specification also in the calculation view. So by displaying this panel on the right, when I select when I work on the electric cables to do my calculation, I see simultaneously the specification text for this part, so not an external document which I have to look up. It's possible to import specifications. So let's say you receive your specification from your client in a format like this, Word document. You can analyze this document and say, okay, here are headers, what is the format of this header? And by entering this into CostFact, saying here that's the client PC Ferris and his specification documents and these types of headers, you can import the document by CostFact, and based on this information, CostFact is running through different sections, analyzing each line. Is this a header? And then, okay, it matches this format, so it is a header. It means the next text, the next section is probably specification text, and splits automatically up the specification to the different elements of the breakdown structure. Then you get a preview, where you have the first columns the content of the headers from your Word document, saying so X for external. So here we have 2530 watertight doors, and then CostFact looks at our own breakdown structure. Does this group exist? Yes, it does. Here it's exactly the same number, same description. Here in some other cases it doesn't. We obviously 2372, that was not available in our own structure. So here it would be necessary to assign it manually. So to select it and then to say that matches the corresponding group in our own system. So here's a preview, and then after confirming, the specification is available in CostFact. The last function, concerning the specification is a very simple consistency check between specification and calculation. So in fact, often when there's something forgotten, the client requires something, has a section describing something, and then working on the calculation where we just miss it. So we have the problem that we haven't calculated this part. Or also vice versa, perhaps we are used to calculate group 500 to something, because we always do. But in this case, the user did, the client did not require the system, and so we waste money because we have something in it and it's not necessary. And CostFact analyzes or provides the possibility to analyze such circumstances by saying, take this specification, analyze either the entire project, or in this case, a group with all subordinated groups, and then saying, show those building groups which are specified but contain no costs, or vice versa, show those building groups which contain costs but are not specified. And when running the analysis, CostFact will show you the resulting groups. In this case, 3 groups which are specified but contain no cost. Then we can export it, then we have our working list. And then perhaps it was alright this way because there's something else calculated, but perhaps we missed something and then we can correct it. Well, finally, all the specification can be exported into an external document, so it creates automatically a table of contents in these things. You have your own logo, and this preview can then be printed or saved as PDF file or also as editable with this Word document. That was specification. The next thing is, and last thing, is life cycle costing, how to optimize the total cost of ownership. That's quite a big break. Up to now, we always looked at the shipbuilding cost, selecting which include the operating cost as well. So perhaps once again, a good point in time to address any questions if you have so far. If not, I continue with life cycle costing. So the main idea of life cycle costing is that the costs that we address when we looking at the shipbuilding cost are only the peak of the iceberg. So that is what is obvious, what we see when we have our design. We see the different systems which are required, and it's clear that will result costs from. But what we do not see is all the resulting costs over the next 10 or 20 or more years when the ship is in service and will incur costs for maintenance, for crew, and all these things. So that is the idea of lifecycle costing to address this cost as well. There's been a couple of analysis how the cost structure is of the lifecycle cost. So here's an example from naval ships, ship program of 10 ships. So here in this case, design development plus production of the ships were 45% together, and the remaining 55% over the service days, 20 years. Of course, the structure depends very much on the type of ship. Here are 3 different types compared: container vessel, bulk carrier, and then petrol craft. So here, container vessel, more than 90% of the cost is fuel cost. On the other side, the petrol craft, here fuel cost is only fuel portion, and the main is utilities, maintenance, and repair. But petrol crafts have expensive systems and IT systems on board, and perhaps if they have to be replaced after 6 years or all 6 years, that will be probably a big amount of cost. And of course, also the costs for the personnel, for the crew, is much higher compared to a container vessel. So, and when trying to incorporate this life cycle cost, one thing is also very important. I already mentioned in the context of ship program calculation, that is the influence of interests, of price increases. So, and what is very typical, not only for shipbuilding life cycle costing, but always when cost calculated for objects which range over long periods, is not to just summarize all costs which incur, but to say we have to discount them or compound them to one point in time. So to discount is just saying if we have 1,000 euro incurring in 10 years, and we know we calculate it now, and we know they will incur in 10 years, that we have a resulting value that is smaller than 1,000 euro. Because when I know I have to pay in 10 years 1,000 euro, I can take 950 euros today, bring them to the bank, I get interest, and when I have to pay it, then it will be 1,000 euro. And so it's currently today less than 1,000 euro. And not necessarily what is typical for lifecycle costing in shipbuilding is to select as the point in time where I discount or compound all payments to the start of the in-service phase. So even if the building phase is 2 years, I say I refer all payments to the first period, to the beginning of the first period of in-service. So that means all the costs during the building phase have to be compounded to this point in time, and all the costs of the in-service phase have to be discounted. So when we look at this and see here in-service phase has a big part, and it's also clear. In this case, we are looking like the ship operator on the ship. So we take the point of view of the ship operator. That means, for instance, that if we look at the costs incurred during the building phase, we also have to add the profit from the shipyard to it. So it's a change of the view from the shipbuilder to the ship operator. So these discounted costs are typically called as discounted cash flow. So one number in the end that is comparable, and more or less that's the theory about the life cycle costing. What is a real problem in practice is to predict the cost during a service phase, because nobody knows about the fuel cost in 10 years. Nobody knows about requirements for maintenance, especially in naval shipbuilding, about IT system cost in 10 years. And that is the main challenge when calculating life cycle cost. So CostFact supported this way, that we have the possibility to define different, here's both German and English, to define different cost types during the in-service phase. So here we have personal cost, fuel oil, regular maintenance, maintaining maintenance, and so on. And based on this, we have this window to enter this life cycle cost. So here we have three main parts. So we have the payments before the in-service phase. There are two different possibilities. Either I take the value I calculated with CostFact. So in the other module, where we also calculate not only cost but based with surcharges or profit and these things, the resulting selling price. So the selling price is relevant because we have here the view of supply of the customer. Or more in detail, when there are different payments agreed during the production phase. So the first payment when the contract is signed, the small payment, and the bigger payment when first steel cut, and all these things, and the last payment is delivery or after 2 years after delivery, then it can be inserted here in a differentiated way. So payments before in-service, then the main part are here the payments during the in-service phase. So here we have the different cost types or payment types we defined beforehand. And here we say for the different periods here related to years, which is the expected cost of the different payment types. They are inserted here. And the third and last panel is about a payment after the in-service phase. It might be when I operate the vessel until it has to be scrapped. Resale for material, but perhaps I say I will operate it the first 10 years, and then I will resell it, then it will be, of course, a higher amount entered there. So and all these costs entered here, for service, during service, after service, are discounted or compounded based on the interest rate, which is entered here. There's always the important question, well, what is a suitable interest rate to work with? The projects I was involved with, we were lucky because it was the client saying, we like to have a life cycle cost calculation as well, and please use 4.5% as interest rate. So it was possible to use this one. In the other case, if there's no such advice, it's up to the user to look at the market prices for interest. So based on this information, here's more on the button. The resulting cash value is calculated. So that means all these numbers, all these costs are discounted, compounded to the beginning of the year number 1, to the first point in time during operation, and we have this resulting cash value. Additionally, we have the so-called annuity that is breaking down the cash value to values of a year. Furthermore, we have all the same in this chart shown. So here we see in the beginning, year 0, at the beginning we have this 70 million or nearly 70 million. So that is the selling price. And then during the service, the cost increases. And then in the end, we have the reduction caused by the resale. So now someone might ask, well, okay, I have the information, lifecycle cost is 136 million euro. Is this good? Is it bad? In which way is this of any help? Up to now, it is not of much help. So the next important thing is the utilization of this information. And there are different possibilities. The first one is to analyze the in-service cost, to say when we like to reduce it, where to focus on. So here we see we have 3 major cost drivers, so we don't care about classification or docking fees. But most important is this lifecycle costing when we have the possibility to decide between different options, between different design options. So, or perhaps when we say, well, we have a calculation of lifecycle cost and we have a competitor and the client wants to compare both proposals. So the client will run such a lifecycle costing. So when I compare something here, I will see in this case, in this window, where I can compare contrast up to 4 different ships or versions, design versions. I have in this example the red one, other one, I don't know the name in English, where we see directly, okay, the investment cost for the client is higher for the red one, but the red line ship is causing less operational cost, less in service cost. And that means after some time, after 30 years or something like this, there will be a change of advantages, and the red one becomes the one with lower cost. And here something else happens. So, but in this case, it might be helpful for me, perhaps, if I'm the shipyard offering the red line ship, to say to the customer, please don't look only at the investment cost at the beginning. We are using long life components. You don't need so much maintenance compared with a proposal from our competitor. And so earlier or later, you are better with our design. So when showing a picture like this to a client or to your top management, there will probably, for sure, be the comment, well, look at this period. All your calculation bases on your assumptions about the costs over the next 24 years. Nobody knows about the price development so exactly. And I'm sure your competitor with this ship will show me the same chart, and he will stay always as the one with a lower cost. So what I'd like to go for is absolutely necessary when calculating life cycle cost and looking into the future is to incorporate the uncertainty such estimations are combined with. And to do so, we have in CostFact the possibility to define such ranges. So here, as an example for fuel cost, we have our basic development, where we said, well, we expect an increase of fuel cost by 3% or whatever per year. And then, referring to this originally assumption, we can pull up this range, saying, well, perhaps it gets much more expensive, plus 80% compared to our original assumption. Or otherwise, caused by fracking in the US, it might get less expensive, and there will be minus 20%. Always not compared to our current price level, but to the assumptions we made. So that can be done for every cost type. And based on this information, okay, here is like the showing CostFact, so here the information is entered in this window. And based on this information, CostFact calculates best and worst case scenarios. So once again, also including the error compensation effect. So perhaps we are less expensive with fuel cost, but we overestimated the cost of maintenance. This is also included. And based on this, best and worst case scenarios are calculated. So best case, so here are 2 ships, or 2 design options, red and blue. Best case would be the lower one with a reduced cost, and red one the higher cost. So here we see in this case, of course, it's a nice example for the presentation, that in any case, based on our assumptions, the red project will be the one with the lower cost. Also, it has in the beginning higher investment costs. And there are also some more possibilities to analyze the uncertainty, so to see how big is the impact of a variance of an input parameter on the resulting cash flow. So here we see, for instance, fuel costs have a very high influence. If fuel cost increases by 50% compared to our assumptions, the total cash flow will increase by plus 15%. So here we have some more information to see about the result of such a variation. Then I can also say, let's say I have 2 different projects, and I say, well, but I have a result, and I like to go for the blue one, but I'm not sure about the cost for the maintenance or for IT replacements. What is it possible that the other one become advantageous compared to this one? And to analyze this, I can select both projects or designs I like to compare, select a parameter I'm not confident with. In this case, it's sustaining maintenance, and here CostFact calculates the variation that is necessary compared to my original assumption that has to take place, that a change of advantages will take place. Here in this case, I see, okay, if the sustaining maintenance reduces by something like 38% perhaps, compared to my assumption, in this case, the blue ship will become the one with a lower cost. And, okay, still I don't know, will it increase or decrease in this way, but then I have some more information to say, okay, no, I think perhaps minus 20% that might happen, but not minus 34% or 38%. Okay, it's still looking into the crystal ball, but a lot of more options, more information to analyze all these risky things when calculated in the future. And to conclude the entire presentation, I have one case study from Flensburger shipbuilders making use of this lifecycle costing module. And here it was Flensburger shipbuilders, a company from the Eastern Sea in Germany, building support vessels, especially a lot of ferries, but also support vessels. And there was one inquiry from the Ministry of Defense from the United Kingdom for a support vessel, and they explicitly asked for a calculation of life cycle cost, provided some information how to calculate it, and what was very interesting, in the request for a proposal, they also said, well, we have our specification here, but you, the shipyard, you are the experts. If you see something and you think this feature that drives the cost very high, so please tell us. So if you have an idea how to reduce cost, please do so. You are free to make an alternative to our specification and to propose how to reduce cost. And so Flensburger did, and in the original specification, it was requested, or it leads to a 2-screw vessel, and that was a basic design that was created by Flensburger. And then the idea, well, how could we reduce costs when we we will go away from the original specification? And the idea was to make a design for a 1-screw vessel. And all the results, or all the combined design options provided. And after doing so, they populated the requested information into CostFact and got this result. So we have the 1-screw and the 2-screw vessel. 1-screw is a cheaper one, a blue one, where we see, of course, it has less investment cost, and also the service costs are lower than the screw vessels. But that's up to now only one side. Now we look at the cost itself. But on the other side, saying, well, in this case, it's clear the blue one is a better one. That would be a big mistake, of course, because a two-screw vessel is better than a one-screw vessel from capabilities. And to incorporate this as well, CostFact Flensburger made use of this so-called value chart. The idea of a value chart is to incorporate both aspects, so both economical aspect as well as the technical aspect. So that is done by saying we have a technical value, an economical value, and if we have, in this case, only two options, the issue is to place both options in this chart. So the economical value, that's quite easy. You might say the cheaper one that has 100% economical value, and if the other one is 15% less expensive, it has 1 divided by 1.15 and has somewhere here an economical value that is a bit reduced. Technical value is more complicated to assess, but often the client provides a scorecard saying, well, we are going to evaluate the different proposals we receive by this scorecard, and that can help you then as well to calculate the technical value. So here in this case, there's only two different options. It was easy, and they said, okay, the one that's cheaper gets 100% economical value. The one with a two-screw vessel fulfills the demands to 100%, so that gets 100%. And then it was to say, okay, now based on the scorecard, what is the technical value of the one-screw vessel? So there's in values, says that economic value was 85% of the two-screw vessel. Based on the scoring model, the one-screw vessel is 69% of the technical value. Well, then it's up to the supplier, to the vendor, or to the client to say what is more important. So in this case, it would be easy to say, okay, 69% compared to 85%. So we are going to the two-screw vessel. But on the other side, if the client is more interested in saving cost, well, so that has to be discussed with him. In this case, it was very easy because the differences between the both alternatives, they were not as big as shown here. Schematic presentation for confidentiality reasons and also to making it looking a bit better. In reality, it was nearer to this, so the cost advantage was not as big as here. And so it was very clear that they offered the original two-screw vessel based on the original requirements. But nevertheless, they were able to say we spent some thoughts and we have a promising tool to calculate life cycle costs and to address this thing as well. That was it. We are nearly in time. 5 minutes late, 12:50, to give you place for questions and discussion. Do you have any questions? Or feedback?
I have a question about your last topic, the optimization and the research of optimal design related to financial aspect or cost aspect and the technical aspect. It's possible to link the software and so the analysis of scenario analysis to other software like I think to Friendship Framework, for example. I don't know if you
I know Friendship Framework from Potsdam.
Yeah, from
Berlin.
Potsdam.
I know Stefan Harris.
Yes. In order to link the estimation of the cost to the, for example, the main dimension of the boat or some specific parameters that are related to technical aspect in this case. It's possible to make this link? Or?
Well, we already have this link with Ship Constructor. So Ship Constructor is a development partner, and they also provide CostFact in the US. And we have an application for funding for a project in 2019 from the National Shipbuilding Research Program. We already created a prototype for the import of the bills of material, but the topic of our project, which we are currently trying to get the funds, is that during the change process, automatically, if a design change takes place in Ship Constructor, automatically in CostFact, a new version is created, and the cost effect of these design variation is automatically calculated in CostFact. So the user will, I don't know if it will happen completely automatically, or perhaps the user will get an alert saying here was a change and our calculated cost is this and this. Do you accept, yes or no? Or do you like to manually control it? But yeah, that is the current stage. So we have a link for the bills of materials and the continuous linking to Ship Constructor is hopefully realized in 2019 in this project.
No, because it's very interesting to have another value in our ranking list of parameters related to costs.
Mm-hmm.
So some measured parameter like resistance or other technical aspect, and then the cost related to each variance. Yes, it's very, very useful. I have also another question, but I don't know.
We have time for questions. So, go ahead.
About the specification, it's possible to manage different specification. I mean, different from the basics, the differentiation in the basic structure of the CostFact preset. I mean, so if a shipyard receives a specification with another structure different from NATO, for example, based on another structure than the NATO, for example, it's possible to import this structure or manage the costs with another.
It is possible. I think I can show you directly. So prerequisite is that the definition, well, the first that you would import the structure from your client. And then perhaps you remember was one form where you can dedicate the group from your client to your own structure group. Say group number ABC from your client refers to group 1600 from our structure. And based on this assignment, you can say here, reference group system. Here it says basic system, that's your own one. But in case you imported before the one from your client, you could select this one, and then during the import, you would have here in this color the numbers from your client's list, and here the according numbers from your own list. So it means you imported, CostFact will transfer it from your client's list to your list, but then you have it in CostFact in your own structure. So you cannot display it simultaneously in the structure of your client. You once transfer to your own one, and then you have it in your own structure. Okay, if there are no more questions, then?
No, I have just to tell something to conclude. 5 months ago, I met one of my friends, and they told me that working on in the shipbuilding, and he's a project manager for quite a big ship of around 120 million euro. And he told me, and I asked him what was the situation of the project, and he told me, we are 10 million out of the budget. Oh, I thought, 10 million, it's an enormous amount of money. You know, yes, but it's less than 10%. And so I have a question for them. Do you have an idea of how is the reduction of mistakes your customer, the actual users of CostFact can get from the use of CostFact? Let me better say, what would be the possible reduction of extra budget expected from our customer, from our shipbuilders, if they could use CostFact? That is, and the second question is, what is the return on investment of CostFact in your experience?
Okay. Well, the question how much will the deviation be reduced, that depends to the client, to the customer. So, but if you remember, we have the different risk classes, and when you make the calculation, you are maybe only have a quick estimate, and you say, well, I have a profit margin of 20%. It's not the end of the world if I will have a cost overrun of 5%. Then you perhaps have an estimated error of plus minus 10%, and then you say, I'm happy, I stop calculating, I go with this calculation into my quotation. And then you will perhaps have in the end 10%, even with CostFact. But the reason is that you before said, well, I have this error, it's a prospective error, but that's fine with me. If you say no, never plus minus 10%, I have to go more in depth, then you would spend more time, ask your suppliers to update their proposals and these things, and then you will have it more reduced. But though it's not possible to say this cost that you have plus minus 5%, because it's up to the user how much.
Okay. But this would be an interesting question to arrange to the actual users of CostFact to ask them, okay, in your experience, how the new ships, the new project is going now that you have more effective tools like CostFact is instead of having the chaos of spreadsheets. So this could be an interesting answer to give to the new potential customers.
But from my experience, everything I heard up to now, the error, the resulting deviation, was always within the deviation calculated by that, okay, how much was it? Well, a few millions.
Yes.
And he told me that the guy had a bad week, but actually the ship was built and that was based on this error, there was a few millions loss for this. And this is what happened because.
Yes, spreadsheets are really dangerous. Okay, so we can close. Thank you for the really deep presentation of CostFact, and thank you for all your time spent with us.
Thank you for your time and for the possibility to present.
But we are going to arrange a new presentation probably in the next month. Maybe we are going for in the CTEC show next spring. We can try to arrange another conference like this where our customers are presented.
Yeah.
Okay, thank you.
Thank you.